about moving files faster. It's about intelligent, a granular collaboration. Now, let's quickly highlight the specific powerful benefits you'll gain with MCAD CoDesigner. First, MCAD CoDesigner cuts down workflow steps by over 50%, as we shown on the previous slide, saving you a huge amount of time and reducing errors on every iteration. Forget chaotic mix of emails, phone calls, meetings, and conversations for engineering changes and version control. MCAD CoDesigner automatically documents every single move, giving you a clear and traceable history so you always know your designed status. When it comes to data accuracy, traditional methods lead to compromised results. MCAD CoDesigner, however, ensures accuracy is constantly maintained, giving you full confidence in your design decision. For component relocation, both ECAD and MCAD teams can now move parts, empowering mechanical engineers to adjust layouts for optimal fit directly in their own tool. And those crucial MCAD references, they're fully maintained after transfer, eliminating tedious rework. Parametric CAD data is no longer lost in transfer. MCAD CoDesigner keeps the data intact, allowing you to modify parts in the native format for flexible and efficient design. For simulations, MCAD CoDesigner provides a copper as a native CAD data ready for immediate analysis without manual recreation like traditional method. Finally, harness designs are now automatically synchronized between ECAD and MCAD, ensuring accurate length calculation and perfect physical integration. As you can see, MCAD CoDesigner isn't just an improvement, it's a fundamental shift, addressing key pain points across the entire ECAD-MCAD collaboration to accelerate product development. So what does all this mean for you? Expect improved design quality. This stems from seamless integration and collaboration between Altium Designer and your mechanical software. When ECAD and MCAD teams work in sync, designs become more robust, accurate, and truly ready for manufacturing. Achieve a faster time to market. True co-design collaboration reduces frustrating errors and costly rework, eliminating common development delays. Getting it right earlier means launching your products faster. And all of this translates into significant cost savings by reducing design errors, minimizing iterations, and cutting down on rework. You directly lower product development costs, less wasted time, and fewer scrap prototypes, means a healthier budget. MCAD CoDesigner isn't just a tool, it's a strategic advantage, elevating your design process for higher quality, faster launches, and greater cost efficiency. Now let's hear directly from someone who uses MCAD CoDesigner. We believe the real proof is in our customers' experiences.
One of the biggest challenges that we've encountered between ECAD and MCAD is data transfer, having accurate and up-to-date information. Prior to laser lamps using Altium Pro, our process was by outputting step files from Altium to then import them into SolidWorks. This is a time-consuming task. It requires a lot of effort on the ECAD side to prep the data, and then again on the MCAD side to bring the data in. So with Altium having a connection tool to SolidWorks, that sped the process up immensely.
The manual process of outputting and inputting step files was a huge drain on their time and effort on both the ECAD and MCAD sides. With MCAD CoDesigner, they saw an immense speed up because the data transfer is no longer a painstaking multi-step. It's about letting the tools do the heavy lifting, not the engineers. We've heard about speed and data transfer, But what about the fundamental challenges of siloed teams? The next testimonial really highlights how MCAD CoDesigner bridges that gap.
So previously the team has worked quite siloed. So avionics and aerostructures both independently design their own systems. Before CoDesigner, that sort of process would have been done using calipers and by hand drawing out where everything sits and measuring everything up. However, now by just simply importing the board into MCAD, we can see exactly where the connector sits on the board and where that board sits within the aircraft itself.
The calipers and hand-drawing days for teams are truly a thing of the past. That image perfectly captures the inefficiency of working in silos. Now, by simply importing the board into MCAD, they gained immediate, precise visibility into connector placement and how the entire board fits within the aircraft. This powerful visual collaboration ensures mechanical and electrical systems align perfectly, saving time and preventing costly errors. We've heard powerful stories about speed, data transfer, and breaking down silos. For our final testimonial, let's bring it all together with a team that pushes the boundaries of integrated design, working on competitive robotics. When you're building something as complex and demanding as a BattleBot, everything counts. Here's Team Rebot to share how MCAD CoDesigner provides the control and speed crucial for the incredible fast turnaround times.
Black Dragon inverted. Oh, what a shot by Rebot! Wow!
The biggest reason I think to go full custom is it gives us control over all aspects of the design.
When I designed the heatsink and the case design, we're pushing the components to their limits. We really have to optimize the heatsink so that we can pull all the heat out and we're not wasting area. Integrating with the entire robot is very tight. Being able to rapidly go in between ECAD and MCAD to change form factors is crucial for their very fast turnaround time.
So before Altium 365, we were reliant on passing files back and forth external to either of the tools. These mechanisms are very clunky, prone to errors, and ultimately they're time consuming.
He sends over DXF, the ECAD designer, imports the DXF, has to align origins. The ECAD designer then has to move 100 components manually.
I worked with Nick a lot pre-CoDesigner. Every single time you import a step file, the MCAD's entirety of their feature tree, if it's using any sort of reference geometry, is all broken every single time. While using CoDesigner, this is no longer a problem.
And what's pretty cool is that I can actually constrain these parts using the geometry from the step file. And this is a pretty cool way that I can communicate to Nick where the capacitors need to go in a way that might be tough to convey otherwise.
The MCAD CoDesigner tool was used to export a relatively simple board, but was critical in the MCAD space for wire management and retention of cables.
CoDesigner allows us to pass board files back and forth very quickly and easily. It also allows us to resolve issues and conflicts in real time, especially if we're screen sharing and on a video call.
Working natively in Altium, he's working natively in his SolidWorks. He can actually define placement of parts. I can send a part on a board. And that's what I think is the biggest time sink.
The overall efficiency using CoDesigner is so much higher, right? The amount of productivity to time ratio is much better. And that helps with two things. One, getting things done, and also just keeping frustration low.
It gives us flexibility that other teams don't have, and allows us to engage in these complex design challenges that you would likely see in industry, but a lot of other BattleBots competitors don't necessarily get to experience.
They perfectly illustrated the frustration of those clunky, error-prone, and time-consuming traditional file exchanges, where parametric data was constantly broken, forcing manual rebuilds and alignments. With MCAD CoDesigner, those days are gone. They can rapidly move between ECAD and MCAD, working natively in their respective tools to iterate on form factors, define part placement, and even communicate complex placement constraints using actual geometry. This translates directly into much higher overall efficiency, boosts productivity, and significantly lower frustration. It's this level of flexibility that allows them to tackle complex design challenges that most teams simply can't. Now we've heard from our customers about the impact of MCAD CoDesigner. To show you exactly how this powerful tool brings all these benefits to life, I'm passing it over to Nikolai, who will walk us through a demonstration.
All right, let me comment on demo, but before we switch to the demo itself, let me clarify where you can get the plugin for MCAD software. Just go to altium.com products downloads and download the plugin for the MCAD which you are using. Then install it and activate it in MCAD. The extension for Altium Designer is available always in Altium Designer, so you can just activate the corresponding panel and start working with that. We will see that in a second, actually. So the first step is to send a blank, simple PCB from ECAD to MCAD. So we see this simple PCB project with the blank PCB shape and with just one connector placed on it. And after activating the panel of MCAD CoDesigner, we can do push and send the design from ECAD to MCAD. And at the same time, we can share the project with the mechanical counterpart. If the mechanical engineer is not part of workspace, he or she will be invited through the administrator. And finally, mechanical engineer should be a member of workspace. Now we see that the PCB was sent to MCAD successfully. And now we will see what happens on MCAD side with this particular project and how to start working with the solution of the plugin in MCAD. Now we see one of the MCAD SolidWorks, which we support, and we see Altium CoDesigner plugin already installed and activated. The process of activation is pretty similar for each MCAD we support. Now, after activating, we will need to log in to our workspace. Yes, now we demonstrate the sign out and sign in again. You can use your Altium account. You can use your on-premise server and enter your on-premise server with the email and password. You can use Google authorization for working with Altium 365, or like in this particular case, you can use your corporate single sign-on for entering your corporate workspace. And after entering the space, we will see that, yes, now we can do pull after choosing the project. So the project created in ECAD. So we need to find it by name. And easily to submit, and after making sure that this is the project we need to pull, just submit it and choose the folder where the project will be saved, change the name if necessary. It is also possible for the project. And now CoDesigner is building the PCB assembly, which will consist of PCB part plus that component, which we saw, plus several auxiliary entities, in particular placement planes and planes which show the ECAD's origin for this particular PCB. That's it for the first step. The second step is shaping the PCB in the context of your device assembly. As you can see, mechanical engineer can easily start editing the sketch for the extrude for the board part. And after changing the sketch according to the shape of enclosure, we will get the shape which is required for this particular design. The simplest way is simply to delete that blank sketch, for that blank initial PCB, and in this particular case to create the contour using offset command. And now the PCB shape is associated with the geometry of the housing of the mechanical enclosure, which is pretty useful for the further changes to the design. By the way, just a side note, for the flex or rigid flex PCBs, the process of editing of the board shape is a little bit more complex, but in general it is the same. It is about editing the sketch of let's say, extrudes for the different PCB regions. And now mechanical engineer needs to place a mounting hole, as you can see on the ribbon dedicated for co-designers commands. We see hole, cut out, keep out, and other commands. Now mechanical engineer creates a mounting hole, choosing the face and choosing, let's say, an approximate position for that hole. And after just picking the approximate point on that face, mechanical engineer will get the initial feature. And after adjusting the parameters for that mounting hole, we see it is created. And now mechanical engineer needs to associate this hole with the corresponding geometry on the mechanical enclosure. For doing that, mechanical engineer will simply start editing the sketch of that hole and associate the sketch with the corresponding geometry on the housing on the mechanical enclosure. Now it is associated and the position of mounting hole is changed. This is the simple operation. Now let's take a look at a little bit more complex changes. In particular, at cutout, keep out, you see cutout created at the bottom of PCB, and we now see the keep out, which is on the right side of the PCB, and we see the properties of keep out, which can be set up by or changed by mechanical engineer and synchronized with ECAD. Now mechanical engineer declares the mechanical enclosure, the parts of mechanical enclosure, which are part of the device assembly, not part of the PCB assembly itself. And now after specifying the enclosure, this PCB can be sent, but before sending, we will also specify or change the placement of this particular connector on this PCB. The placement of connector can be also synchronized or associated with the geometry of mechanical enclosure. For example, it can be associated with the corresponding slot in the mechanical enclosure, but now mechanical engineer just applies simple move component command and moves the connector to the position to some position on the PCB just for demonstration. And let's now see how the PCB is synchronized back to ECAD with all the changes made in MCAD to the shape, to the location of connector, and with the cutout and keep out created. After putting a comment, the PCB is pushed from MCAD to ECAD, and we can now see the history. The history is saved, and it is pretty useful and transparent for seeing what was sent and when. And moreover, any particular electrical push can be pulled by mechanical engineer. For example, for reverting the design in case of making mistakes in it. And now we see the initial design, and we see the notification from the mechanical engineer on CoDesigner panel. And now CoDesigner analyzes changes and allows to apply all of them or part of them, and allows to preview the changes. And now, after applying all the changes, we will see what will happen with the PCB. We will see that the PCB shape is changed, the mechanical enclosure is transferred and represented here in ECAD, and we will see the entities, the PCB entities created by mechanical engineer. Now we see the enclosure, which is useful, by the way, for doing the collision checks directly here in ECAD. It will save a lot of time for electrical engineer for the further component placement and for the further design of the PCB. And we see that the keep out is represented by the native electrical entity, by the native PCB entity. Same was with cutout. It was the dedicated cutout entity. And now we see the mounting hole, and electrical engineer applies plating to that mounting hole. And that plating, we see the preview now, and that plating will be represented properly on MCAD side as well. We will see that. And as a continuation, electrical engineer is going to create the copper tracks to do the routing itself. And now, let's say dummy tracks are created just for illustrating how the technology works and illustrating the result, which we will get in MCAD. And yes, after creating these tracks, the PCB can be first saved here or saved to the server and sent to MCAD by using CoDesigner's panel. Just as a side comment, once again, the PCB can be now pushed automatically on saving PCB to the server. But in this particular case, electrical engineer does the manual push with the comment. So now the design is being pushed back, and we will see the result in MCAD. Again, all the history is here, and we will see the notification in MCAD. Yes, after switching back to the main interface, we see the notification, and before pulling changes, mechanical engineer wants to build the precise geometry of copper and vias here, including copper barrels, by the way. And now, after pulling and applying changes, we will see the result of this synchronization, this step of synchronization. And in particular, we will see the shape, the 3D geometry of copper created by CoDesigner here. This is the real 3D geometry of copper. This is not just a picture. And as a bonus, I would like to comment on demonstration of synchronization of multi-board project. Now we see a multi-board project which consists of two PCBs plus motor plus harness, which interconnects those components. We see the electrical design of that harness, so-called wiring diagram. Now we see the topology of that harness, which is represented in so-called layout drawing. And now we see the harness which was transferred from that electrical project to MCAD and already 3D routed. Initially, it is transferred in flat state, but now it is already 3D routed. And now we see that the mechanical engineer makes changes to the physical length of segment and to the physical length of wires. And this is, by the way, one of the key purposes of synchronization on harness. CoDesigner will bring the physical length of wires and harness segments from MCAD to ECAD so that those entities with the proper physical length will be represented on the manufacturing drawing created here in Altium Designer. After expanding one of the records here in this changes table, as you can see, it is very similar to what we saw for PCB. And after applying changes, we see that the length is changed, and now it is represented on the manufacturing drawing for wires and harness segments. And finally, the synchronization for the entire multi-board project. So mechanical engineer now links or establishes the linkage between the device assembly in MCAD and the corresponding multi-board project with the multi-board schematic diagram. We see it. And after the linkage, this design, this assembly with the parts of enclosure specified for the synchronization is being transferred from MCAD to ECAD. And now, after the same procedure, after the applying changes in MCAD CoDesigner panel, we see the result. So the entire assembly is now synchronized, and electrical engineer can do the corresponding checks, collision checks, measurements right here in ECAD. That's it. Now, please, question.
All right. Well, thank you, Grace and Nikolai. It really is incredible how far the EDA tools have come in enabling the crossover between mechanical and electrical design since I've been in the industries. Before we close out this All About PCB's live session, I'd like to announce our prize winners. Congratulations, Jerry Higuchi and Andrew Day. We'll be in touch with you within the next week to ensure we have the information we need to send you the All About Circuit swag bag. In a moment, you'll be redirected to Altium's Summit Series microsite. I encourage you to check out other live sessions, keynotes, and published content for our month-long virtual event. Thank you for attending the All About Circuit Summit Series 2025.